Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about primitive root in a group. This is the concept which we are going to use in our coming concepts in cryptography. And in our last classes, we already discussed about order of an element, order of a group concept. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, when order of an element is same as order of a group, what is the order of a group? Number of elements in a group that we identify using phi of n. These discussions made previously. When order of an element is same as order of a group, that is phi of n, then that value we call it as a primitive root. Then that element is a primitive root. With example, you are going to get good understanding. Let's take a group G is equal to Z8 star over multiplication. These type of groups we are considering here. So Z8 star means, Z8 means in the elements that less than 8 and relatively prime to 8, 1, 3, 5, 7. The order of this group is 4 elements. So phi of 8 is 4. Now you need to identify order of element. Order of element 1 power 1 congruent to 1 mod 8, that is order is 1. So 1 is not equivalent to 4. Order of an element should be same as order of group. Then only we say it as primitive root. It is not primitive root. Similarly, order of 3 is 3 square congruent to 1 mod 8. 3 square means 9. 9 mod 8 means 1. That is 1 mod 8. That is equal to. So the order of 3 is 2. It is not equivalent to 4. It is not a primitive root. Similarly, order of 5 is 5 square congruent to 1 mod 8. So order of group is order of 5 is 2. So this is also not primitive roots. Order of 7 is 7 square congruent to 1 mod 8. So the order is 2. This is also not primitive root. The point you need to understand, all groups don't have primitive roots. Some of them will have, some of them don't have primitive roots. This group don't have a primitive root. Let's take one more example which contains primitive roots. Z7 star over multiplication. What is the phi of 7? 6. The order of elements that present in the group is 6. 6 elements. 1, 2, 3, 4, 5, 6. And order of 3 is 3 power 6 congruent to 1 mod 7. See, 3 power 6. So the order of 3 is 6, which is equivalent to order of a group 7, Z7 star. So 3 is called primitive root because the order of element 3 is 6. Similarly, order of 5 is 5 power 6 congruent to 1 mod 7. So 6, order of 5 is having order 6. This is also primitive root. So you can have multiple values having primitive roots. That is the point you need to understand. So in this group, we are having 2 primitive roots that are 3 and 5. So whether the group contains primitive root or not, there is a shortcut to identify that group contains primitive root or not. Let's do some examples on that. The group G will have primitive roots if n is either 2 or 4 or p power t or 2 multiplied by p power t. If this satisfies these conditions, then that group contains primitive roots. Let's do some examples. G is Z17 star. 17 is a prime number. Here p is prime number. P 17 power 1. T is some constant. 17 power 1, which is a 17. So p power t. This can be n can be written like this. Then this group contains primitive roots. Similarly, Z38 star. 38 can be written as 2 multiplied by 19. 19 is a prime number and 2 multiplied by 19. This can be written as 2 multiplied by 19 power 1. So 38 is also having primitive roots. Similarly, Z50 star means 50 can be written as 2 multiplied by 5 square, where 5 is a prime number. This can be written as 2p power t, 2p power t. This is also having a primitive root. So this is the shortcut used to identify the group contains primitive root or not. Hope you understand what is meant by primitive root and some examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.